I'd like to talk a little bit today about edge effects. It was confusing to some of the students that were in my summer course. And so basically I want to just go over some of the pictures and images that are in your Canvas notes. So that you have this image both in the Canvas pages and in your lecture notes. This is from a conservation biology textbook. And this is showing you a square reserve that's 1,000 meters by 1,000 meters. And hypothetical edge effects for this model reserve penetrate 100 meters in from the outer boundary of the reserve. This line here represents the outer boundary of the reserve. This line here represents 100 meters from that outer boundary. We have the same thing here. The outer boundary of the reserve, edge effects 100 meters in, and then the inner boundary of the reserve. So the interior of the reserve is 64 hectares, and hectare is a metric unit of measurement. 1 hectare is 2.47 acres. And so what this picture shows is what happens when you fragment an area. And so in this next image, we've basically taken this reserve and we've thrown a road through the middle of it, and then we've sent a railroad across it. And even though the road and the railroad do not take a whole lot of room inside the reserve, it significantly has increased the edge effects because, again, the hypothetical edge effects penetrate 100 meters from the outer boundary of the reserve to the inner boundary of the reserve that's not affected by edge effects. So our original reserve, we have an interior space of 64 hectares that's not impacted by edge effects. But once we've bisected this reserve with a road and a railroad, our interior space is 8.7 hectares there, 8.7 hectares there, 8.7 hectares there, and 8.7 hectares there. And each of these 8.7 hectare chunks is impacted by edge effects that penetrate 100 meters. And so by putting a railroad and a road through this reserve, even though it doesn't take a whole lot of space, we now have an interior space of 34 hectares. Whereas our original reserve had an interior space of 64 hectares. And so we've basically cut the effective undisturbed area of the reserve almost in half. The other thing I want to mention are area to perimeter ratios. And that has a lot to do with the shape of the reserve, if it has a jagged edge. And this is a simple example, again, from a conservation biology textbook. But a spherical reserve that's 100 kilometers square will have a smaller perimeter than a rectangular reserve that's also 100 square kilometers, just due to shape. And what you want is you want a high area to perimeter ratio. You want a lot of area compared to perimeter. So I just threw some numbers on that. If we have our spherical reserve and our area of the reserve is 100 square kilometers, and the edge is 20 kilometers, our area to perimeter ratio, 100 divided by 20, gives us an area perimeter ratio of 5. With our rectangular reserve, we still have 100 square kilometers of interior reserve, but we have 40 kilometers of perimeter. Well, 100 divided by 40 is 2.5. So we have a lower area to perimeter ratio, 2.5 area to perimeter ratio for our rectangular reserve, a 5 area to perimeter ratio for our spherical reserve. And again, you want to have a high area perimeter ratio. You want a lot of area in the reserve compared to the amount of edge or perimeter outside that reserve. where did all this come from? Well, you will be reading an article by Thomas Lovejoy in Smithsonian Magazine where he did a study called the Minimum Critical Size of Ecosystems Project. And in that study, he worked with ranchers in the Amazon basin when laws changed where a rancher had to keep half of their ranch forested. Half of the ranch had to have trees. And so he worked with ranchers to have islands of tropical forests surrounded by a sea of cattle pasture. And those islands of forest ranged from 10 hectares to 10,000 hectares. And he looked at extinction rates on these islands of different sizes. Now, when you look at an uncut tropical forest that hasn't been fragmented, the sunlight can only penetrate from above. There's a multi-layered canopy. The vegetation is really thick. Sunlight can't penetrate from the sides. It only penetrates from the sky above. And so fragmentation has a huge effect because once you have an island of forest surrounded by a sea of cattle pasture, you're not only going to get sunlight penetrating from above, but you're going to get sunlight penetrating from the sides. And so anyway, we have 1 and 10 hectare isolated forest fragments here. Here's a 1 hectare isolated forest fragment. Here's a 10 hectare isolated forest fragment. And after several years of isolation, you can see this small island has undergone a change. You can see some of the trees have blown down and we have shrubby vegetation there. And that is because of edge effects. The edge of this island have been exposed to sunlight. It has been exposed to increased winds, which knock trees down, and decreased humidity. And the other thing he talked about in his study was what happens if you have a small island of forest connected to a larger island of forest by a corridor. And one of the things he found there was extinction rates would go down if you had a corridor, because if one species went extinct in the small island of forest, then species from the larger island of forest could use the corridor to recolonate. Let me go back. Another thing he found is because the small islands of forest ended up being mostly edge effects had a great impact. The species extinctions, the extinction rates were much higher on these small islands than were predicted by species area curves. Because the smaller the island, the greater the amount of edge in proportion to interior forest. And so in the lecture notes and your Canvas notes, you have this diagram. And this diagram shows how far edge effects penetrate in a tropical forest. And notice that first picture I showed you was assuming edge effects only penetrated 100 meters. Well, it turns out in real life in a tropical rainforest, increased wind disturbance penetrates almost 400 meters into the forest. And that increased wind results in elevated tree mortality because the trees dry out due to decreased humidity. And also trees are blown over. And so because of all these changes, you get reduced soil moisture, you get reduced humidity, you get tree fall, you get the death of trees near the edges, and you get a change in species composition in that tropical rainforest. And so edge effects can be significant, especially if you have a lot of fragmentation going on, whether it's a tropical rainforest or an old growth forest. So anyway, I hope that was helpful. Make sure you go over and look at these diagrams and understand what these diagrams are talking about.